All right, so when we're dealing with sequences, remember sequences are functions that take the natural numbers as their domain. So we denote the terms of the sequence this way. So those are the terms of the sequence, right? The first term is A1. That means we're plugging 1 into the function, and A1 is the value we get. The second term is A2. We're plugging 2 into a function, and A2 is the value we get, and so forth and so on. And AN, of course, is the nth term. All right, what we're going to do, actually, let me give a little bit more detail. There is AN out here. That's the nth term, and then it continues on beyond that. So we have videos, or I've made videos where we find AN for a given sequence. What we're going to look at now is we're going to look at what are called the sums, or the partial sums of these sequences, okay? So let's see here. If we take the terms of the sequence, and we add them up, A1 plus A2 plus A3 plus plus AN, and we add them all the way up, all the way to infinity, all the way up to A infinity, right? The infinite term. We just keep adding and adding and adding. Well, we're going to use a little bit of notation for this. This is called the sum. This is sigma notation. That's the uppercase Greek sigma. And we're going to take the terms of that sequence. We're going to take the terms of the sequence, and we're going to add them up beginning with I equals 1. So the first number that we're going to look at is 1, and then we're going to count all the way up to 3, all the way up to infinity. We're going to count all the way up to infinity. All right? We call this the sum, or the series for this particular sequence. So this is the series. This is the infinite series. We're adding up all the terms of the sequence, okay? And let's say we don't want to do that. Let's say we only take 2 plus A3. Let's say we only go up to the nth term, and we stop it there. We don't go any further than the nth term. Well, we're going to use this notation, same notation. It's the sum from I equals 1 to n now. So instead of going all the way to infinity, I'm going to stop there at n. The sum from I equals 1 to n of all the ai. These are the individual ai. This is the index of the summation. I, it starts with 1, and it uses the counting numbers all the way up to n. So 1, 2, 3, 4, 5, 6, all the way up to n, basically. So that's the notation. And we're also going to have a more simplified notation for this. Instead of s, we call this Sn, which is the nth partial sum. So we have the series, which is the sum of all the terms of the sequence, and then we have the nth partial sum of the sequence. So this is the nth partial sum, all right? What I want to look at is I want to look at what happens when we look at not just any arbitrary sequence, because that was just an arbitrary sequence. What happens when we look at an arithmetic sequence? So for an arithmetic sequence, the distinction here is we start with A1, and then every subsequent term we have a common difference that we are adding to A1. So A1, we're going to add the difference. This is going to be A2. A1, we're going to add 2 times the difference. This is going to be A3. And then you add all the way up to, it's going to be AN is A1 plus n minus 1 times the common difference times D. And of course, you can continue that on as far as you want. Okay? There's another way of representing that, actually. There's another way of representing that. Let's say we want to talk about only the partial sum, right? Let's say we don't want to go all the way up to infinity, but we want to truncate this at AN. So this is A1, A2, A3, A4, A5, all the way up to, this is AN, okay? We could also write that this way. We could write it, instead of starting with A1, we could start with the last term, AN, and then subtract d every time. So an would be the first term. It's the largest term. Well, not necessarily the largest, but it's the term that has the highest value for its input. And then we're going to take an minus d and an minus 2d, and you would continue in this fashion all the way down to an minus n minus 1d. So we write it in two different ways. We start with a1 and just add d every time all the way up to an. This will be the value of an here. Or we start with an and we subtract d every time all the way down to a1. This would be a1. All right? Now, we can write the sum in both of those ways. That means the sum from I equals 1 to n of ai could be written as a1 plus a1 plus d, this term, plus a1 plus 2d, this term, plus dot dot dot, plus a1 plus n minus 1d. So you could write it this way. You could write it this way and call this Sn, the nth partial sum. And you could also write it the other way, the sum from I equals 1 to n of ai. You could, instead of starting with a1, start with an, the last term, and subtract d each time. So it would be plus an minus 1d plus an minus 2d plus plus an minus n minus 1d. So I'm just adding this and I'm adding this, but they're both the same thing, just different representations of the same set of numbers. So let's see, this is also Sn, the nth partial sum. So what I'm going to do is I'm going to take these two things and add them together. So I'm going to take Sn and add Sn. I'm going to take these two rows and add them together. So I'll get Sn plus Sn, this plus this, equals, and then I'm going to add these two representations. So it's going to be a1 plus d plus a1 plus 2d plus dot 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 plus a1 plus n minus 1d. And to that I'm going to add plus, I'm going to add this one right here, an plus an minus d plus an minus 2d plus dot 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 plus an minus n minus 1d. And let's see what happens here. Well, on the left hand side, let me erase up here. On the left hand side here I have 2Sn. 2 times the nth partial sum is equal to, well, what happens over here? Well, I have a1 plus d, but I also have an minus d. The plus d and the minus d would cancel. As a matter of fact, the plus 2d and the minus 2d would also cancel, and every term that has a factor of d would actually cancel out. So this term that has a factor of d cancels that term, and here's what you'd be left with. a1 plus a1 plus a1 plus a1 n times. So you would get equal n times a1 plus, and we also have an plus an plus an plus an, that's n times also, so we have n times an, or 2Sn is equal to n times a1 plus an, and in that case we see that the nth partial sum for an arithmetic sequence or for an arithmetic series is Sn equals, you divide both sides by 2, you get n over 2 times a1 plus an. And that would be the nth partial sum of an arithmetic sequence. So let us take a look at an example. Let's see. let's find the nth partial sum of, and let's take a look at this sequence. Let's try negative 12, negative 8, negative 4, 0, 4. So, and I want to find the nth partial sum where n is equal to, let's say n is equal to 40. So I want to find the 40th partial sum, which means I'm adding up A1 plus A2 plus all the way up to A40 for this sequence. Right here. Okay, well, let's see. A1 is a part of my formula. A1 is given. A1 is negative 12. So A1 is equal to negative 12, A1. A40 is something else that I need, and I'm told that n is equal to 40, so that's given. The only other thing that I need to know is the 40th term. The 40th term. In order to find the 40th term, I have to know what the nth term looks like. So let's find the nth term of this arithmetic sequence first. Well, the nth term, let's see. There's a common difference here. The difference here is 4. The difference here is also 4. Difference here is 4. Difference here is 4. So since these are all equal, this is an arithmetic sequence with common difference 4. The value of d, the common difference is 4. So I'm going to use the formula for an. An for an arithmetic sequence is equal to a1, which is negative 12, plus n minus 1 times d, which we just found to be the number 4. So this is an. You can simplify it to make it look like a linear function by distributing, and you would get that an is equal to, let's see, that's going to be distribution gives me negative 16 plus 4n. Because 4 times negative 1 is negative 4, minus 12 is negative 16, and then 4 times n is 4n. So this is an, and they want me to find the 40th term. So I know that a1 is negative 12. Let's see what a40 is equal to. A40 is going to be negative 16 plus 4 times n, plus 4 times 40. All right, so that's negative 16 plus 160. So that A40 is 144. So this is the 40th term. So there I have the 40th term, A40, and I have the first term, and I also know that n is equal to 40. So by this formula, the 40th term then, well, let's actually move it down here then. By this formula, what we're looking for is the 40th term, S40. The 40th partial sum, sorry. The 40th partial sum, we need the 40th term to calculate. So the 40th partial sum is equal to n, which is 40, over 2, multiplied by a1. A1 is negative 12, plus an, and an is 144. So this will be the nth partial sum. This will be the result of adding negative 12 plus negative 8 plus negative 4 plus 0 plus 4 plus 8 plus 12 plus 16, all the way up to the 40th term, which is a 144. Adding all of those up produces this number. 40 divided by 2 is 20. And then 144 minus 12 is 132. 132. All right, so then we have 20 times 132. That's 0, 4, 6, 2. So 2,640. So if you take all the terms, of this sequence between the first term and the 40th term, including the first and 40th, and add them all up, the sum that you would get would be 2,640.